Hello, everyone, and welcome to July 2023's Integration Down Under. Tonight, we are good to have Kent Weare from the product group. I'll go through the organizers real quick. We got Martin in Perth, Dan in Brisbane, Mick in Sydney, Wagner in Auckland, and myself here in Melbourne. And tonight we have Kent Weare. And how long have we known each other, Kent? It's been a while.
Probably 15, 16 years, I would guess.
Yeah, because I was an MVP in 2004, and you weren't much after that, I don't think.
I think it was 2007, roughly, give or take, yeah.
So, okay, so let me go ahead and pass over to Kent now for the talk tonight, and I'll be monitoring the questions in YouTube. So if you've got any questions, please post them into the chat, and I will bring them up to Kent. So let me remove my slides. I'll add Kent's to the screen, and we'll go just full screen with his. So thank you very much, and carry on, Kent.
Yeah, it sounds good. Let me just go full screen here as well. And thanks for having me, everyone. Please do ask questions. It's 2:07 a.m. My time right now, so I'm definitely looking for some energy from the rest of you who've been up for more than 30 minutes. So, but no, it's a pleasure to be here. Thanks for having me. Today, what I'm going to talk about is the new custom code capabilities. Here, let me hide this.
Okay.
That are found in Azure Logic Apps standard. I'll have some content that you might have seen before, just in case people haven't seen this, and then I've got some new content here as well. So just some background on the capability or the feature itself. So what we've enabled here is the ability to go ahead and call .NET Framework code from a built-in action found in Azure Logic Apps standard. And we'll get into full demos here shortly, but until we get there, what you see here is a visual code experience. And when you are on a workflow, we've got a built-in action here called invoke a function in this Logic app. And what this function or what this built-in action is going to do is it's going to look for compiled code that's been written in a specific manner that allows you to go ahead and discover it and subsequently call it. And we'll certainly get into more of those details throughout the demo itself. Now, the first question people are probably going to say is, okay, why .NET Framework? Why aren't we sort of using other languages or other versions of .NET? And the answer is really just around BizTalk, right? So this feature was really born out of the need for customers moving from BizTalk and looking to migrate some of their scenarios. So, we do know, obviously, folks that have BizTalk installations, you've more than likely built helper functions, helper methods that you would love to be able to move forward. In most cases, hopefully you have that source code. In some cases, you might only have to compile DLL. And in both of those cases, we want to help you move forward. I know this is going to come up, so I'm just going to sort of address it right now. What about like .NET Core? What about .NET 6 or, and whatnot? And so that is something that will come. It is something that our model is quite extensible. We can solve or sort of support, .NET Core and other languages. We will go to GA first with .NET Framework. And once we've GA'd that, then we'll look to add additional language support. Would love to hear what languages people are interested in. I feel like .NET Core is sort of a natural. At the Integrate conference, we got a lot of feedback around PowerShell. So that's kind of interesting. I think the big thing I would look at it is if function supports that language already, it's something that we can actually support relatively easily. Because under the hood, what you actually are is you are writing a function. The difference here is that you don't need a separate service plan in order to like run that code. This is something that gets executed in the same service plan as your workflows. And I think that's a feature that customers are naturally quite interested in. I think the other thing that is largely beneficial is that you will not have another surface that you need to secure. This is something where it's running on the same box as your workflows, and there's not another security surface that you have to take care of. And so that naturally becomes a bit of an issue sometimes for customers, because now they need to either store keys or implement a security mechanism in order to lock it down, which isn't required. And obviously another benefit is lower latency, because this is running on the same box. You're not actually hitting the wire per se in order to go ahead and call it. So some other capabilities that we enable is, and this is I think another benefit, is local debugging for both workflows and your code. And so we're going to see that in the demo, where we can jump between debugging our workflow and debugging our code through your standard F10 or F5 keystrokes in order to move through various breakpoints. If you were building logic apps and functions today, chances are you were having multiple VS Code instances, and trying to debug them was probably a little bit cumbersome. And I feel like that's probably something that's been addressed here. Another thing that's interesting and was super important for us was this support for dynamic schema and inputs and outputs with complex types. So this idea that if you are creating your function in your code, and you've got different inputs and outputs that you're expecting, that experience in the workflow designer should be exactly the same as if you were calling an out-of-box connector, if you were calling Dynamics, or you were calling SharePoint or whatever. Like, you should have a similar experience between your code and what you're used to seeing today. And I think this is some of the work that we've put in that I'll talk a little bit more about in the demo, but it's quite interesting in my mind as well. And that's kind of just the brief intro and some of the benefits that we do have. Let's go ahead, let's jump ahead. Now, what are some of the top use cases for using this capability? Naturally, when we talk about logic apps and we talk about like a low code designer drag and drop, I think that still holds. Like, that's still a goal that we want to provide. But I think the reality is whenever you get into some more complexity, you need an extensibility option, and you might need to be able to write some custom business logic, and doing a whole lot of if then else statements in the designer may not scale to sort of your needs. You might have a lot of different dependencies that you're juggling, and being able to implement that in code might be advantageous for you. Certainly doing calculations would be of interest. Yes, we do have some of those workflow language definition functions that allow you to add, subtract, multiply. When you're doing sort of a lot of calculations, those may not scale as well for you, or actually may not be very easy to debug or understand. So the ability to put that into code and write tests against it and step through the code is probably something that's going to be a little bit more supportable long term than having this massive expression chain that you sort of copy and paste in and out of Notepad. Custom parsing to extract information from an inbound message. I think we've kind of all been there, where we get some gnarly, ugly, sort of large payloads, and we might want to do some parsing around that. And once again, having some custom code may lend itself better than some of the other alternatives. Data validation. I remember early on in one of my earlier BizTalk projects, we used to use something called Schematron, where we would basically be able to do some additional validation, and being able to call that from .NET might be interesting, or it might just even be your own validation rules that you're going and checking. If this value is this, and this value is that, and this value is that, then that's okay. But if this is some other value, you could sort of check for those situations. I would also say some simple transformations as well. Like, obviously we've got support for the BizTalk map, like where you've been able to generate XSLT or even the new data mapper that we've been working on that's in public preview. Those are still advantageous for graphical mapping, but once again, I think we've all been there where, sometimes doing something in code might be the best path forward. And instead of you having to externalize this, you certainly would be able to write that code using this method. Another thing that does come up from time to time is message shaping for outbound messages to another system. So maybe you need to go ahead and call an API, and maybe you need to take information from multiple sources and be able to construct basically a request body. If you can do that inside of the HTTP action and that works for you, great. But if there's more complex needs, certainly this would offer opportunities there as well. And then the last two were ones that I ran into even this week with customers looking to go ahead to use like encryption and decryption. And in this case, we're definitely not suggesting go roll your own, but you might have situations where you have like PGP encryption needs that sort of aren't addressed out of the box for you, and you use some .NET libraries today to go ahead and do this type of work. The ability to go ahead and do that in this local function is certainly an option that you can do, and same thing with compression, decompression as well. So these are some options as well. Naturally, a question that will come up from time to time is, well, so what about the role of Azure functions? And the way I like to look at it is that functions are still valid. Like we're not saying don't use functions. We've just got a lot of feedback from customers looking to reduce some of the friction that's involved in setting that up. And as I mentioned before, like under the hood, you actually are calling a function. So I don't feel like you're sort of losing anything by using this approach. I think the biggest sort of thing to think about is like, where does it make sense to more tightly couple your code with your, say, integration project versus when would you want to centralize it? So I would look at a situation where maybe you've got like a more of a service, like you've service enabled some sort of functionality, and you want that to be more central. And that might be a situation where multiple logic apps, or maybe even something outside of a logic app needs to consume. That would definitely lend itself to creating a function, centralizing it, and treating it more as a service. Versus you might have some logic that is more related to your integrations, and that is sort of better met or better managed together, and that would be an opportunity to lend itself with the the approach that we're talking about here. So I've got I'll pause on the slides for now. Let's go ahead and do sort of the initial demo, and then I'll have come back to the slides here in a little bit. As I go through this, I'm going to sort of pause along the way and get into a lot of details just around like what we were thinking when we went through this, and give you perhaps some more details that we haven't seen in some of the other presentations. So I'm in VS Code here, as you can see, and the way we've enabled this experience is by clicking on like the Azure A, and we are now underneath this menu here, the Azure Logic Apps menu, enabling a sort of a new entry point called Create New Logic App Workspace. So if you've used VS Code before, you've definitely used the Create New Project. That will continue to support, but it's one of those things where Workspace is going to become more prominent in sort of how we build these solutions. So as Wagner's working through some investments around like the local dev experience, it's going to be largely sort of leveraging Workspace. And you can kind of think of Workspace is kind of like Visual Studio Solutions. It's kind of a similar concept in that regard, that we can sort of have like a sort of a top level basically artifact that will then be able to link multiple projects together. So what we're going to do is we've got almost like a wizard-like experience that gets enabled through this workspace. And the first thing that we're going to need to do is to provide or select a folder. And so I'm just going to go ahead and select a folder for this. And I'll create a new folder. And so inside of this folder is where our workflow project and our code project is going to be stored. Now, the first thing I'm going to get asked now is the name of the workspace. This is basically the workspace file name. So this is rather arbitrary. So I'm just going to go ahead and provide that. Now, the next input I need to provide is the name of the function. Once again, this can be sort of anything that you want it to be. I'm just going to call this get weather because like this initial demo is just focusing on getting the current weather. Now, the next option we can provide here is the namespace for this specific functions project. I'll go ahead and provide a name there. And because we're going to provision some sample code for you, we're also going to provide a sample workflow so that you can quickly go ahead and get started. Like our goal is that you should be able to get this running within a couple minutes. You should at least have a hello world working instance that you can go ahead and then build upon. With private preview, there was a ton of manual configurations that we had to make. It would probably take you like 20 minutes to get this going. And our goal is to be able to do that within a minute or two. So here I'm just going to select a stateful workflow, and I'm just going to then call this my workflow. And we'll open it in the current window. So this will take a couple seconds. Now, what we've got here is the workspace. So you can see the name of the workspace, that the name that we had provided. We then have a functions project and we have a logic app project. And so what this does require is one of our sort of core principles was that we didn't want to intermix our functions with our logic app. We didn't want to change the structure of our logic app project. And so we do separate these two. So we've got a separate function, or a separate project rather, for our code and a separate project for our workflows. Now, the big thing is that Logic Apps naturally needs to be able to locate this code. When we compile it, we're going to see a new folder show up here called lib custom net 472. And so the Logic App is really looking for compiled assemblies. It doesn't really care about the source code itself. So you can kind of think of this as, doing all of your work around code, and then before Logic Apps can use it, then being able to go ahead and compile it. Now, if we go ahead and take a closer look at the functions project, what we'll see ahead and we pre-configure for you. And these are all sort of necessary that you would otherwise have to wire up yourself. And, we take care of it for you. And more specifically, it's around like the settings and where we sort of have some additional sort of paths that we want to be able to sort of to leverage and to use. And then also our tasks here as well. Like we need to make sure that we are, going to use like the .NET debugger for this specific project itself. And so these files differ from our Logic App files. The other thing that we do have here is, let's go into the CS proj. We've got the Logic App folder name, right? So we need to be able to know where we deposit our compiled code. So that's a little bit of a hint. And then we also have build tasks. And these build tasks are once again pretty important because, as I mentioned, the Logic App project doesn't care about the source code. It cares about the compiled code. So we have some references around like cleanup, where when you go ahead and issue a build, we're going to clean up that folder, and then we're going to basically go ahead and write to that folder after the fact. The next sort of key sort of file here is basically the sample code that we actually go ahead and provide. So we've got just this, generic, get weather function that we go ahead and provision. We've just got something here that sort of allows you to quickly get familiar with this capability, and naturally you can go ahead and sort of remove this and tweak as you see fit. But some of the things to notice here is, we've got these references. If you create an Azure function, like these are going to be the same using statements that you see over there. We've got the name of the function, right? So we prompted you for that. That's where that value is being deposited. We've also got a namespace here as well. That was something that we captured early on, which we've now gone ahead and implemented here. And we've got this sample method that you can go ahead and leverage. Now, this is kind of the key piece here. We've introduced a new trigger type, and it's called workflow action trigger. This is the entry point to your code. And so this is something that our team wrote and is published as a NuGet package that gets pulled down with this template type. This is what allows you to go ahead and call this code. And so you can't call this code outside of from a workflow. And that's somewhat deliberately because we don't want to manage another entry point into this code. We don't want to have another security surface that you have to deal with. Now, in terms of inputs and outputs, we kind of did this, deliberately just to sort of demonstrate the different types that we support. So here we've got just an integer, we've got a string, and then we also have a complex type here as well. So below here, we've just got like a simple complex type that just sort of demonstrates that, hey, you can go ahead and use complex types. The example itself doesn't make a whole lot of sense, but it's just something that just demonstrates sort of different inputs and outputs. And we could definitely take complex types as inputs as well. So this is just going to do some randomization and spit out basically a complex type, and you'd be able to go ahead and use this from inside of your workflow. Now, before I go ahead and compile it, I just want to sort of open up the workflow itself. So we'll just give this a second for the designer to load.
Hey, Kent, real quick, is this in preview now? And when do you expect it to go GA?
Yeah, so this is in public preview, and I would expect sometime in the fall. Sometime in the fall, we should see this reach GA. So for sure before the calendar year, but hopefully quite sooner than that.
Thank you.
Yep. So here we've got this local function, and you can see we've got an error, and this is for good reason. Like in our template, we've got it wired up so that whatever function name you had provided as part of that input, that wizard, is pre-populated here. And so this just goes to show you that the local action here is trying to find compiled assemblies that just don't exist yet. And so what we need to do is we need to go ahead and to compile that. So what we can do is we can either go to terminal and run the build task, or we can just go to new terminal. And the other thing to think about when using this is always think about the context in which you're trying to do something. So I'm trying to compile code. So I want to make sure that my functions project is in scope. And so once I've got that in scope, I'll see a new terminal. And I can now go ahead and perform a .NET restore, which will take care of addressing all of these, dependencies that are sort of unmet here. So we should see these squiggly lines disappear here shortly. And so there we go. And now I need to go ahead and perform a .NET build. And once I hit the enter key, we're going to see a new folder pop up here called lib. And that just will show that we've now bin placed our custom code. We've taken the output from the functions project and basically put it into the correct folder on the Logic App side. So it's still compiling. Now that's done, so we can go ahead and see it. So if we expand this lib, net472 or lib custom net472, there's our DLL that we, from this particular functions project. Now, if you've ever done anything with the XSLT plus .NET framework support, so if you've ever taken a BizTalk map, generated an instance of it, then gone ahead and copied that XSLT into your Logic Apps project, and you had a scripting functoid that used a custom assembly, this is that same folder structure where you would have put that helper assembly. And so basically anything related to .NET shows up in this particular folder. Also, if you're using SAP, I guess it's not in the, or I guess, sorry, it's in the service provider, so it's up a folder. But yeah, this is where we sort of centralize on net472. So in the future, when we support other languages, you can envision lib custom some other folder that would manage those assemblies itself. Now, the other thing that's really important here, and we'll see this even more so in this next demo, is that we go ahead when we compile this code, we create a folder here for that specific function, and we put in a function.json file for it. This is what allows us to use dynamic schema. When we go ahead and I flip back to the designer, we're going to be able to select this function from a dropdown. That is because of this functionality. And the other thing that's really important here is that we have all of the inputs and outputs modeled. So for example, here we can see we've got zip code, and this is an inbound parameter, and that zip code is of type integer. And then same thing with temperature. Temperature is of type string. If we look at the output side of things, here we've got an object, and basically we've got all of these properties, and these are required. So this is quite important, because as we come over to this particular step, now we can see that error is gone, and basically it can find this specific function. Now, just to show you where you'd find this, let's go ahead and let's just delete this action, and we'll go ahead and re-add it. So this is built in. So if we go in here and just type local, we'll go ahead and find it, and we can just go ahead and add it. And when we click this drop down, where is it? Why is it not finding it? Of course. There. I don't know what's going on there. I haven't seen that before, but what it's done is it's gone in and it's looked in this specific folder for a function.json file, and then it's found one for get weather. So if we go ahead and select that function, then we'll dynamically display or sort of allow you to select the input parameters for that specific function. So I'm just going to provide a zip code here. And we also have like a temperature scale that we need to go ahead and provide here as an input. Now, you're probably asking, okay, well, what about the output? So we do have naturally a body here, but that's not good enough. We want to be able to access the individual properties for that complex object. So what I'm going to just do here is just type some text here. And now I can use the dynamic content. So here we've got all of the outputs. So we have a body if we want, but we want the individual properties. So the weather in this zip code is, and then we can go ahead and select another value here. Current weather. So we'll go ahead and we'll save that. So at this point, now we want to go ahead and try this out and do some local debugging. So if we go and look at our workflow.json, we can set a breakpoint. So here, we'll go ahead and just set the break. And then we'll go into our code and set a breakpoint, let's say here. Now we need to sort of enable the debugger. So of course we do need to make sure Azurite is running. And in this case, we want Azurite to run in the context of our Logic app, because that's essentially what uh, are working on avoiding you from having to click that 3 times. So we should have this all running. And then what we want to do is start up the debugger. So we can, in this case, we want both. We were going to go ahead and start up the Logic App debugger. And then we'll also attach to the .NET framework debugger as well. So this will take just a moment to get started.
So, Kent, if you wanted to use like the PGP and that library, you just add that to your function app as a reference to a NuGet package or something for that PGP library, and then you just do the little bit of stuff that you needed to do in your function to do that decrypt or an encrypt.
I think you were talking about basically if you had another assembly, and that's actually the next demo that I'll get to.
Okay, very good.
Yeah. So we've got the Logic Apps debugger running. Uh, the big thing there is like you want to make sure. Let's see if we scroll up. Okay, I missed it. But okay, so we've got the Logic app. You'll see kind of the endpoints being loaded, that's how you know it's working. Then what we'll do is, this is a lighter weight operation, attach the functions as well. So now we've got both of them. You can see that 2 is there. That shows that we've got both the Logic apps and the code debugger. Now, in order to invoke this naturally, much like any other sort of Logic Apps VS Code project, we can go into Overview. And you know, when you see this URI and the run trigger button, that means you're in good shape. So okay, I'm having some issues here. Let's see. think StreamYard and
Yeah, we've had this a couple of not lately, but we did have it at one time. We had issues with some of that screen refresh.
okay, all I'm gonna do here is just issue a request from Postman.
Yep. Okay.
Yeah, I don't know what's going on.
Okay. Looks like we've lost Kent for a second. Let's see him to come back, and we'll get started back up on that. And again, while Kent's just coming back on, if anybody's got any questions, please just type them into the question. Let's just and you're back, Kent. You want to share your screen again, or you're going to try to do that, get the demo results, and then share your screen?
Yeah, let me do that actually, because that I don't know what's going on. Everything was fine before I got on here. So yeah, just give me a moment. If there are any questions in the meantime, let's go ahead and take some of those.
That's what I put out there. I haven't seen any so. Oh, okay. Got one question. So if I add a multiple logic apps into the workspace, can all logic apps consume the weather function? So yeah, it should be just like anything else, because any standard logic app, if you had 5 logic apps in that standard logic app, it should just be able to call that weather app.
Yeah, so I think, sorry, you're getting cut off there, but if I got the question right, so if you have existing workflows, how do you go ahead and sort of get to call the code? Is that the Yeah, and so I have a video on my YouTube channel that talks about that, and so we kind of did that deliberately, where we will go ahead and it's easier to add workflows to this new workspace concept than it is to add custom code to an existing work. Basically, you just need to like copy those workflows into the new workspace, and then from there, basically, just wire it up, and it's quite easy to do that.
Okay. One other question: any gotchas for the CI/CD pipeline?
No, not that I'm aware of. We've got customers actually using this in production, and they were able to get this deployed with CI/CD. So I think the big thing here is like, you manage your code the same way you would any other sort of piece of code. So the big thing is leveraging the build task and compiling your custom code first, and then basically making sure that the assemblies are bin placed prior to deploying your workflow project. So I think like that's just kind of the key is just doing that first. But otherwise, yeah, there should be no sort of real difference there. As I mentioned before, like we're focused on, get the code compiled, then get it into the workflow project, and then the deployment would be just like any other, deployment. So I was able to just start the debugger again without sharing my screen. And here we can see we do have a local breakpoint. I can then go ahead and step through that. Actually, we're going to have a bunch of these now that are sort of all queued up. And then now here we're into the code. Naturally, we've got like, if you hover over different values, you can see the local variables here. That all works as you would expect. So I can now step through the code line by line. I've got a few instances queued up. That's why you see the same line being called, but you can go ahead and step through all of the code. If you go ahead, then you can obviously hit F5 to sort of step through like, the rest of the code or to the next breakpoint. So those are all sort of the experiences that you would expect to see inside of VS Code. All work fine from that perspective. If you head back to the overview, some of these, I think, because we called it a bunch of times, but you will see the run history being sort of available here, and you have the ability to go ahead and look through the run history and see all of the inputs and outputs as well, much like you would expect with any other actions as well. So yeah, that's that is the debug experience. Now the other piece, just to sort of finish the presentation, there was a question about like, what do I do with existing assemblies? And so the scenario here is we've got like, say, a BizTalk solution, and as part of this BizTalk solution, maybe there's a helper class that we've gone ahead and built and are wanting to use in our Logic app. And so it's obviously quite simple just for demo purposes, but here we've got just like a static class with some static methods that we want to be able to pull into this Logic Apps project. So what we can do is inside of the CS_proj file, basically just include some references. Now, these could be absolute paths that you see commented out. These could be relative paths as well. And then basically just referring to that .NET helper. When this gets compiled, naturally, it'll get placed inside of a bin folder in the code project. And we will naturally want this to make its way over to the Logic app folder as well. Now, if you have NuGet package, great, even better. You should be able to just add the NuGet package to the project. That should just work. And then we will take care of bin placing your custom code and your referenced assembly, and we'll make sure that those make their way into the proper folder in Logic Apps as well. So that's kind of sets us up for the second demo. So let's just close this workspace. And I'll open the project itself here. And so if we take a look at this is where I'm going to reference this specific assembly that I've pulled in here. And we can see like it's in this, bin debug net472 bin folder is where it's going to get pulled from. And so that's up here inside of this folder. Then if we go ahead and take a look at our code, we're going to go ahead and add our using statement here so that we can go ahead and load that assembly. And then what I've done is I've added another function. So we could create another .cs file here as well, but what I've done is just added basically this attribute, the function name, and then as I mentioned before, we have to have the workflow action trigger as our trigger type as well. So I can copy and paste this and add multiple functions. The big thing is they need to be unique. So we need to have a unique name here for the function, and then our method name needs to be unique here as well. By default, we'll have this run method. You can only have one method with that name, so you can call this kind of whatever you want. Now, this is just a static class, static method, so that's why I'm just going to go ahead and do that in line. But we can now go ahead and call this. So much like we did before, we do need to go ahead and compile this code. And when we compile this code, we will bin place it into the workflow project. And so we should see here after this is done, naturally that this is going to show up in the workflow project. Okay, so that's complete. Now we've got the net 742, we've got the assembly, so that's great. We've got both the custom code project and we've got the assembly. And so like the one question might come up, well, can I just call the assembly directly? And you can't call it directly because we need this plumbing, right? We need this workflow action trigger as that entry point. So in general, there will be a little bit of work for you if you want to use existing assemblies. You essentially have to sort of wrap it, if you will, for that to work. But what also is interesting here is now we have two folders. We have this prepend HR string folder with function.json, and we have the weather forecast too. And so this becomes important if we go into our workflow designer, because now what we'll see is when we have the dropdown, those two options should show up. So let's just let the workflow designer load. And if we go ahead and select this, now from the dropdown, we'll see both, right? So if we have weather forecast 2, or in this case, the prepend HR. So that will allow us, and obviously these parameters change and the outputs will change depending upon what you've selected in that dropdown as well. Now the local debugger will work the same. In this case, I probably won't run it again, but yeah, you'd be able to set a breakpoint in your custom code and then see that you're calling the assembly itself. So yeah, that's kind of it for content. Happy to sort of take any additional questions if people have any questions.
Okay, there is one question out there. How does the workflow designer know about the nature of the function, signature, input, output?
Yeah, so that's really when we bin place the assembly in the workflow project, that's really generating this function dot input and output bindings. And so here we've got an input, and it's basically a string, and then in this case we have an output and it's a string. If we look at the weather forecast, which is a little bit more involved, we've got a zip code, and the zip code is so that's why like the build task is really important. Whenever you're making changes to your custom code, especially like you do need to compile it, and then when you compile it, we'll Any other questions?
Yep, there is one other. Can you please elaborate on how I'd reuse existing XSLT maps with this? Did you hear me, Kent? It's about whether we can, there it is.
Oh, sorry, Bill, you got cut off.
Okay, can you see the question on the screen on? Can you please elaborate on how I'd reuse existing XSLT maps with this?
Oh, how to use the XSLT map direct like this. Really, the only piece that's kind of shared here is like the folder structure. So when you go ahead and have an XSLT file that assembly, it's going to look for it in this lib custom net472 folder. We don't allow you to sort of directly sort of like debug those like through this mechanism. This is more for if you're authoring sort of new code. And yeah, there's a
Okay,
like
yeah.
I said, a video on my YouTube channel.
Okay. Any other questions? I don't see any more questions, but I'll put that other thing up there about questions. And thank you very much. I learned a lot. I didn't realize that it was that function based, and I think that that's got a lot of interesting implications that we're going to be able to leverage with this. Because I know there's a lot of times that people have leaned towards functions instead of logic apps because of that. So I think this is going to be good.
Yeah, thanks. I'm pretty excited
Okay.
about it. I think it's going to be part of probably every project. So.
Okay, thanks very much. And on that, I'm going to end the broadcast. That recording will be up on our Integration Down Under site just shortly. So thank you very much again, Kent, and go have some sleep.
Yeah, thank you.